Okay, on the example number 2, what we have here is a 30 kg disc. Okay, and we also have a force P here, 50 Newton, and the angular velocity of the disc is actually 10 radian per second, and we need to determine the tangential and normal components of reaction of the pin on the disc and the angular acceleration of the disc at this instance. Okay, angular acceleration of the disc at this instant, this one is the alpha, and the tangential and normal component, which is here, we can put it as like that, and this one O N, and this one is O T. Okay, the normal and the tangential component on this particular pin at point O. Okay, now we begin with the acceleration, the tangential acceleration of this this. Okay, it is equal to alpha rg. Alpha is the angular acceleration of the disc. Okay, and rg is the radius of this particular disc. Okay, 0.3, and the normal acceleration is equal to angular velocity square times the rg. Okay, and the angular velocity is given here, 10 radian per second. Then just plug in all the values, then we get this the normal acceleration of this. Okay, using the parallel axis theorem, this one, we can determine the mass moment of inertia of the disc on this particular point here, point of rotation, this. Okay, by definition, for a solid disc like this, the mass moment of inertia is equal to half m r square or md square. Okay, m is given 30 kg, and this one is the radius of this particular circle. And then we have to plus with the md square. M is 30 kg, as same like this one. Okay, and the d is actually the distance from the center of mass to this point O. Okay, it is the d, which is 0.3. Okay, and then you will get this mass moment of inertia of the disc on this particular point O. Okay, moving on, we calculate the moment at point O. Okay, and we assume that counterclockwise is a positive direction. Okay, now what we have here is we can see from the P here, if you look into each of the component, okay, there is the P Py, there is Px, okay, where the Px is equal to 4 over 5 times 50 Newton, where the Py is equal to 3 over 5 times 50 Newton. Okay, and here we can see that Py, okay, this one is Py times the distance, which is 0.3. Okay, so Py times the perpendicular distance. The distance from this one. Okay, perpendicular distance, which is 0.3. And then plus, okay, this one is positive because it will go that way, okay, counterclockwise. So it is positive. And then how about Px? It is the same because Px will rotate this counterclockwise as well. So it is positive. So that's why we have a positive sign here. And it is your Px. And 0.3 is actually the perpendicular distance from this one. Sorry. Okay. The force is acting here, and the perpendicular distance is this one. So it is again the same 0.3. And then it is equal to I O times alpha. IO we already calculated here. Okay, 4.05 kg meter square. And then we can solve this equation to get this angular acceleration of the disk at this instant, which is 5.19 radian per second square. Okay, now the next part, we want to calculate the normal component of reaction at the pin O. Okay, we calculate the summation of forces in the normal direction. Okay, going up is a positive direction. So now we have the ON. Okay, ON is this one. Forces is going up, and then plus with the PY. PY is 3/5 times 50. This one PY, and then minus the weight of this of the disc. Okay, weight of the disc, which is 30 times the gravity. Okay, then that is equal to the m times the normal acceleration of the disc, which is we already obtained here. Okay, 30 meter per second square. Then you can calculate the normal reaction at pin O. Next is the tangential forces, summation of tangential forces on that particular system. Going to the right is positive direction. Then what we have is the OT here, okay, tangential forces, point O. And then what the next is we have a PX, which is equal to 4/5 times 50, because the direction is same. Then that's equal to M times A, the tangential acceleration, which is alpha R. Okay, alpha R. Okay, and then we can determine finally we can determine this tangential reaction at pin O, tangential component of reaction at pin O. Thank you.